For more than 4 decades, Voyager 2 has been drifting steadily away from everything we know. Launched in 1977, guided by commands written on Earth before personal computers even existed, it moved past Jupiter's storms, skimmed Saturn's rings, glanced at Uranus and Neptune, and then kept going. Beyond planets. Beyond sunlight. Beyond the familiar gravitational order of our solar system. A machine never meant to return, never meant to survive this long. A ghost ship, powered by fading nuclear warmth and humanity's curiosity. For years, scientists expected Voyager 2 to slowly fade into irrelevance, its signal dissolving into background noise. But it didn't. Instead, it kept talking. And then, unexpectedly, it said something that made engineers and physicists stop and stare at their screens. It wasn't just a routine transmission. Not a scheduled data dump. It was a sudden spike. An abrupt shift. A hard line crossed. Voyager 2 had reached the edge of the Sun's dominion, and what it found there shattered decades of assumptions. Music. The boundary Voyager 2 crossed is called the heliopause. It marks the outer edge of the heliosphere, the vast magnetic bubble created by the solar wind as it pushes outward against the interstellar medium. For decades, scientists believed this boundary would be gradual. A soft blending. A slow fading of the Sun's influence into the galactic background. That is not what Voyager 2 experienced. One moment, it was inside the Sun's protective cocoon. The next, it wasn't. Radiation levels jumped by more than 70% almost instantly. Plasma density increased sharply. The magnetic field didn't slowly twist or dissolve, it snapped into a new configuration. The transition was so sudden it stunned researchers. It was as if Voyager 2 had stepped through an invisible wall. Not a blur. Not a gradient. A boundary. The data showed that the heliosphere is not a weak, leaky envelope. It is a structured, shield-like barrier. A membrane holding back the full force of the galaxy. Inside it, radiation is filtered. Charged particles are deflected. Space weather is relatively stable. Outside it, Voyager 2 was exposed to a chaotic environment dominated by galactic cosmic rays and turbulent magnetic forces. The solar system, it turned out, is not simply floating through space. It is protected. And Voyager 2 had just stepped beyond that protection. The readings were sharp, aggressive, unmistakable. Particle energy surged. Magnetic fields shifted direction. The calm, familiar environment shaped by the Sun vanished in an instant. The textbooks were wrong. The heliosphere doesn't gently dissolve into space. It holds the line, until it doesn't. Even more unsettling was what Voyager 2 revealed about the heliosphere's behavior. It isn't static. It breathes. The boundary expands and contracts with the Sun's 11-year activity cycle. When solar activity weakens, the heliosphere shrinks, allowing more galactic radiation to creep inward. When the Sun strengthens, the shield pushes outward again. Voyager 1 and Voyager 2 didn't cross the heliopause at the same distance, or even under the same conditions. The difference wasn't random. It was rhythmic. Solar. This means Earth's cosmic shield is not permanent. It fluctuates. It thins. It retreats. And beyond it, the environment is far more hostile than we ever imagined. In 2019, Voyager 2 went silent. For a few tense hours, all communication ceased. Every instrument dropped offline. No commands were sent from Earth. No response came back. Then, just as abruptly, Voyager 2 recovered. Systems rebooted. Signals returned. Officially, the explanation was aging hardware. A routine glitch. But buried in technical analyses were strange details. Unexplained electromagnetic disturbances just before the outage. Sudden fluctuations in particle energy. Magnetic anomalies that didn't fit neatly into existing models. The unsettling question wasn't just why Voyager 2 shut down. It was what it had just passed through. Some researchers suggested a dense plasma region. Others proposed shock waves from distant supernova remnants. But a quieter, more troubling idea lingered. What if Voyager 2 encountered a layer of interstellar space we didn't even know existed? A zone with properties so unfamiliar that its interaction with the probe caused a system-wide reaction. If that's the case, the blackout wasn't a failure. It was exposure. Once outside the heliosphere, Voyager 2 began recording something else that defied expectations: patterns. Not random noise. Not isolated spikes. But structured fluctuations in radiation and plasma density that behaved almost like weather. Waves of high-energy particles. Shifting magnetic directions. Rhythms that repeated over time. Interstellar space was not empty. It was active. Scientists tried to link these disturbances to solar events, but the timing didn't match. The patterns aligned instead with distant galactic phenomena, stellar winds from faraway stars, ancient supernova shock fronts, the background pulse of the Milky Way itself. Voyager 2 wasn't drifting through a void. It was sailing through an interstellar sea. One of the most shocking discoveries came from the magnetic field data. Models predicted turbulence at the heliopause, a violent clash between solar and galactic magnetic forces. Instead, Voyager 2 found near-perfect alignment. The Sun's magnetic field and the interstellar magnetic field beyond were oriented almost the same way. This was not supposed to happen. Either the Sun's influence has shaped the surrounding interstellar environment over vast timescales, or the region of the galaxy our solar system occupies is already magnetically ordered in a way we never predicted. Both possibilities are unsettling. Aligned magnetic fields could create channels that allow cosmic rays to stream directly into the solar system during quiet solar periods. Pathways. Open doors. Not chaos, but structure. And that realization sparked an idea few were ready to voice openly. What if the heliopause isn't just a boundary? What if it behaves like a threshold? The sharpness of the crossing. The consistency between both Voyagers. The alignment of fields. The responsive nature of the boundary. Some scientists began to wonder whether this region behaves less like a passive interface and more like a reactive zone. Not intelligent. Not designed. But dynamic. Layered. Sensitive to intrusion. Every object that exits the solar system doesn't simply leave. It announces itself. Voyager 2 may have done more than measure conditions beyond the Sun's reach. It may have triggered a response we don't yet know how to interpret. And attached to Voyager 2 is something else. A golden record. Etched onto it are sounds of Earth, music, greetings in dozens of languages, diagrams explaining human biology, and precise instructions for locating our planet. A cosmic message in a bottle. A hopeful gesture meant for whoever, or whatever, might find it. For decades, it was celebrated as optimism made metal. But now, with the heliosphere revealed as a sharp, reactive boundary, the message feels different. If crossing that edge is not subtle, if it is noticeable, then Voyager 2 didn't just carry a greeting beyond our solar system. It carried our address. With every transmission it sends, Voyager 2 confirms our intelligence, our technology, our persistence. It whispers into the galaxy that we exist, that we are curious, that we reached beyond our shield. Voyager 2 was never meant to survive this long. It was never meant to reveal that the edge of our solar system is not gentle, not soft, not forgiving. It confirmed that we live inside a protective bubble, and beyond it, the rules change. Radiation intensifies. Fields align. Space becomes structured, active, and hostile. The boundary is real. It is sharp. And beyond it feels less like open ocean and more like a gate. So now the question hangs in the silence between stars. Was Voyager 2 merely an explorer? Or was it a signal? Do you think Voyager 2 discovered something unnatural at the edge of our solar system, or simply revealed how little we truly understand about the space beyond our sun's reach? The universe is watching quietly. And for the first time, we may have knocked on its door.